In section 1.4, we're going to be talking about angles. An angle is made up of two rays that share an endpoint. So in this picture right here, if we start at A and travel through B, we have a ray. Then if we start at A and travel through C, we have additional ray. Then we would call this whole thing an angle. And the angle, is really talking about that, not distance, I don't want to use distance, but how far we've traveled from here to there in terms of degrees is one way we can measure angles. So an angle has two rays, and the endpoint that they share is called a vertex. And the rays, we call the rays sides. So we've got one side up here, we've got an additional side down here. When we go to name angles, actually in this case there's going to be three ways we can name this angle. The easiest way doesn't always work, but when it does work, it's the shortest, easiest way to name an angle. And that is to call, we use this as an angle symbol, we call it by its vertex, which the vertex here was A, so we can call it angle A. But many times we cannot get away with that. So we have to give alternatives. And the alternative ways use three letters instead of one. We still use the vertex, but the vertex has to be the middle of the three letters. And the other two letters, there has to be one letter from each side of the angle. So here, this side up here travels through B, so we could use letter B to represent that side. And then it travels, the other side is through C, so we could use C to represent that side. So angle BAC. Now, those two sides can be interchangeable, so we could have started with C, traveled through a vertex of A, and then through the other side of B. That would be allowed as well. So knowing that, let's take a look at number 1. They want us to give the three names. So we could name an angle Q, the vertex. And then the two sides go through N and T, so we could call it NQT or TQN. They also say to name the vertex. Vertex is just the point where the two rays intersect, that's Q, point Q. And then for the sides, they are both rays, so we'll label them as rays. One of them is QN, so ray QN. The other one is ray QT. Next, let's look at some angles, and we'll talk about their measures. Notice down here in front of each of these angle symbols, we put the letter M there. The letter M there means the measure, means we're talking about how many degrees it is. So what they're saying here is, here's the measure of angle A. It's less than 90 degrees, but it's more than 0 degrees. If that's true, you probably know this term already, but we call it an acute angle. That is a classification. If the measure of angle A is equal to 90 degrees, that's a right angle. That would be its classification. When the measure of angle A is less than 180 degrees, but yet larger than 90, so it's between 90 and 180, that we call an obtuse angle. That's its classification. And then if the measure of angle A equals 180 degrees, notice it looks like a line, and it is. If that's true, if it's 180 degrees, we call it a straight angle, for obvious reasons. So let's practice on number 2, classifying these three angles. If angle D, technically they should have an M in front of it, they're talking about the measure. The measure of angle D is 90 degrees, that would be a right triangle, that would be its classification. Sorry, I think I said triangle, I meant angle, right angle. B, we'd put an M in front of it. Technically, it should be there. The measure of angle B is 136 degrees. Well, that's more than 180, or sorry, more than 90, but it's less than 180. So therefore, it's an obtuse angle. And once again, should be a measure of angle C. It's 27 degrees. That means it's less than 90 degrees. Therefore, it is an acute angle. Next, we're going to take a look at the angle addition postulate. Previously in this chapter, we had a segment addition postulate. The angle addition postulate is similar, but now we're talking about angles. Let's start with a vertex, and I'm going to draw an angle. So the vertex is A, and then I'm going to put points on these sides, B and C. And so let's say we're talking about this angle. I'm going to draw a little arc here to represent that angle. Let's say we go that many degrees, however many degrees that is. But then I don't stop there. Maybe I keep going until I get to another side. So let me draw another ray off of A. We'll say it goes through point D. So now I'm going to stagger my arcs because I want to show there are two different arcs, two different angles. So I'll start there at the side of C, and I'll travel to the side of D. If I went this first number of degrees, however many degrees they were, and then I traveled that many more degrees, how many degrees total did I travel? Well, it will match the measure of the entire angle if I started at B all the way through D. So the two portions together add to make the entire thing. So we can label it this way: the measure of the first angle. Here's an example where we cannot just say measure of angle A. Because if I tell you to look at angle A, you will not all look at the same angle. Some of you may look at this upper angle and call that angle A. Some of you, if I say look at angle A, you might be looking at this bottom angle. And some of you may be looking at the big angle. So there are three different angles there that have a vertex of A. So I can't just call it angle A. I have to use three letters. So if I want the top letter, I'll use A as the middle letter, but then I have to pick a letter on each side. So this side goes through B, so I have to include that. The other side goes through C, so I have to include that. So angle BAC. So the measure of the angle plus the measure of that second one. So it has a vertex of A, so that's its middle letter. One side goes through C while the other side goes through D, so I could call it measure of angle CAD. If I add those two measures together, it should equal the measure of the entire angle. The entire angle has a vertex of A, so that'll go in the middle. And the two sides go through B and D, the two extreme points at that point. So B and D will flank the A when I name that angle. So that's the angle addition postulate. Now we're going to go to the other side where we actually apply it algebraically in this problem. Now notice they tell us in number 3, if the measure of angle GFJ, let's stop right there. GFJ, F is the middle letter, so that's the vertex, which makes sense if you look at the picture. And they're going through G and J. So one side goes through G, it'd be this ray right there, the other side through J. Okay, that looks like we're looking at the entire angle. I'm going to draw a little arc to represent that. That entire angle right there is, and that's just the total, is 155 degrees. But I see that it's made up of two smaller pieces, this piece, this piece. Well, that angle addition postulate says take those two smaller pieces and add them together. When you do that, they will equal the total. So the sum of the two parts is equal to the total. Let's go ahead and now simplify the left side. We have like terms that we can combine together. Solve this algebraic equation. I will subtract 3 from both sides. And lastly, I will divide by 8, giving us 38. Sorry, 19. I think it's 19. Sorry, I divide one more time. Yeah, 19. Okay, now that's not the answer to the question, so make sure you read the instructions closely. That helps us, but now we have to find the measure of GFH. So we have to start at G, go to the vertex of H, and then through of F, go through H. So the rays go through G and H. Oh, so that's this 4x plus 4 piece. Measure of angle GFH. So it's this 4x plus 4, but I'm going to substitute in 19 for my 4. 76 plus 4 is 80 degrees, I believe. All right. And then the second one, HFJ. So I have to travel through H and J as the rays, so it's the 4x minus 1, but I'm substituting 19 in place of the 4. So we get 75. And just to confirm, do those two numbers in fact add to 155? Yes, they do. So I'm confident that we did that correctly. Okay, next, congruent angles. We talked previously about congruent segments. Well, congruent angles are angles that have the same measure. So how do we show that in an angle? Instead of saying it looks like they're the same size, how do I know for sure that they're the same size? How can I mark on the picture? Notice I'm using two separate vertices, so I can get by with naming them just a single letter. If I want to show that those two angles are supposed to have the same measure, they're not perfect by any means, I can use a single arc, or even a double arc or a triple arc, as long as the number of arcs I use match. That would imply that those two angles are congruent. So I could say angle A is congruent to angle B. That's what's represented in that picture. Now we also talked about segment bisectors. Now we're talking about an angle bisector. So an angle bisector is something, it's usually going to be a ray, that cuts an angle in half or divides it into two equal parts. So it divides an angle into two congruent parts. Okay, so I've got an angle here. Let's call it A, B, C. And if I want to do a bisector, I'm going to start at B, travel right down the center. We'll say it goes through D. And to show that I went through the center and that they're divided into two equal parts or congruent parts, I mark the two parts congruent. I stagger my arcs so you can see they're two separate arcs. And so now if I want to represent this symbolically, I would say angle A, B, and then it goes up through D as the smaller one, is congruent to angle D, B, C. Those two parts are congruent. And I could also say that ray BD bisects the big angle, angle ABC. Those are things I could say. And so now you can take a look at these problems and do them. XWY is 29 degrees. Right here we see that they're both 29 degrees. So now we should be able to find XWZ, the entire thing. We add them together. And number 5, we're told that it's bisected in the instructions, so that means these two things are congruent. Therefore, the algebraic expressions are equal. So you can set that up, and then you can solve that, and then you'll have to plug your x back in to find out what the measure of angle ABC is. And I will let you finish it from there.